Here we discuss how to determine the coordinate of center of gravity of a quarter of circle, right? That is of a quadrant of a circular area. We first draw a rough sketch of circle. This is the total circle. Okay, let it be origin, and this is the positive x-axis and this is the positive y-axis. Positive y-axis. And here we consider the first quadrant, that is the quadrant OAB. Okay, and clearly this quadrant is not symmetric about any of the axis, that is about the x-axis or not about the y-axis. So the coordinate of CG is G is given by x bar y bar, neither of x bar and nor of y bar be 0. Okay, and here we have to find two value x bar and y bar to completely determine the coordinate of CG. Now we first find the value of x bar, and here the equation of the circle is taken as x square plus y square. This A is radius. Okay, now to find x bar we consider a strip parallel to y axis. Okay, this, and let the strip is considered at the point P xy. This is lies on the circular arc. Okay, so the coordinate of this point, this is PM, is given by x, 0, because this is on the x axis. So the length of the strip, this is equal to y. Okay, and strip is considered at a distance x from the y axis, and let its breadth be dx. So the area of this strip PM is given by, this is the elementary area, this is given by dx into y. Clear? This is the length and this is the breadth, and we have to find an elementary mass, that is dm. So this is given by rho y into dx, because elementary mass is density into area. Okay, we write here in place of dA, this is y into dA. Right, now taking moment of all the strip about y-axis and get the total moment as integration. This is x equal to 0 to a, and this is x into dm, because the distance of the elementary mass from the y-axis is x. Okay, so this is distance into dm, and the left side is given by the coordinate of G is x bar y bar. So we get, this is the total mass and this is x bar. Now what is the total mass of the quadrant of the circle? To find the total mass we must integrate here. This is integration x equal to 0 to a, and this is dm, right? So we put in place of a, this is integration x equal to 0 to a, this is dm, so this is x equal to 0 to a, dm means rho y dx. So we get the value of x bar, this is equal to integration x, this is equal to 0 to a x dm by integration 0 to a y into rho into dx. And what is the value of dm? The value of dm is rho y into dx. Since rho is constant, so we cancel out rho from both terms and get integration 0 to a x into y dx. What is y? Y is given by root under a square minus x square. So we put here a square minus x square into dx by integration 0 to a, this is root under a square minus x square into dx. Right. Now for the upper integration we put a square minus x square, this is equal to z square, so minus 2x dx, this is equal to 2z dz, and x dx, this is equal to minus z dz. Right, now we changing the limit of integration from x to z, this is 0 to a, obviously this is a to 0. So the upper integration is integration a to 0, this is minus x dx means z dz, z dz, because we take minus here, and root under square minus x square is also another z. So this is the upper integration, and the integration in the lower term we put here, the formula of this integration is as x into root square minus x square by 2 plus a square by 2 into sine inverse x by a. Okay, and the limit is integration 0 to a. So by integrating upper side we get the range becomes 0 to a, we vanish minus sign and get zq by 3, the range is 0 to a. And for the lower term we get this is 0, because for x equal to a this is 0, and for x equal to 0 this is also 0. So we get from here a square by 2 into sine inverse 1, because at x equal to 0 sine inverse 0 means 0, and this gives a q by 3 into 2 by a square into 2 by pi, because sine inverse 1 is equal to pi by 2, and get the result as 4a by 3 pi. Okay, so we get x bar, this is equal to 4a by 3 pi. Now we consider the strip parallel to x axis to find the value of y bar. This type of strip we consider, and the length of this strip is obviously this is p xy, so the length must be x, and we take breadth is y, and the distance is y. Sorry, this is dy. So our this type of integration converted to y bar into integration y, this is equal to 0 to a, this is rho x dy, right, because it is dy, and the right side is integration y, this is equal to 0 to a, and this is y dm, and here dm, this is equal to the length of the strip, this is x, the breadth of the strip, this is dy, and the rho, this is the density. So we put here this is rho x dy, and by similar type of integration, here the integration with respect to y, and but in this term integration is respect to x, and otherwise the integration are same type. Okay, and getting the same result as y bar, this is equal to, we write here y bar, this is equal to also 4a by 3 pi. Okay, so the coordinate of CG of the first quadrant of the elliptic area is given by 4a by 3 pi, 4a by 3 pi. Right, now if we consider the second quadrant in place of first quadrant, then the coordinate of CG is g x bar y bar. Okay, and obviously this coordinate is written as minus 4a by 3 pi, 4a by 3 pi. Right, if we consider the third quadrant, then we get this is minus 4a by 3 pi, and this is also minus 4a by 3 pi. And if we consider the fourth quadrant, then we get the coordinate of g as this is positive, so 4a by 3 pi, minus 4a by 3 pi, because here y axis is negative, and in this position x-axis and y-axis both are negative, but in the second quadrant only x-axis is negative, so x bar is negative. Okay, so we get in all the four cases, if we consider a quadrant of a circular area, then we find the coordinate of CG by similar method. Okay, thank you for watching.